We've seen trigonometric functions, sine, cosine, and tangent. Let's review them really quickly and then we will use them. So the trigonometric functions, and trigonometric is just a word that means it has to do with triangles. This beginning trigono really comes from talking about triangles. Don't worry about that. Just know that anytime you see trigonometric or trigonometry, or it's often referred to as just trig, we're talking about sine, cosine, tangent, the things we've been dealing with. They have, right now we're going to use them to relate to a right triangle, and we're going to focus on one of the two acute angles in that triangle. So I'll choose this one here, and I'm just going to put a little theta in there. And from that, when we're focusing on that angle, the three sides have specific names. The one across from the 90-degree angle doesn't matter what angle we're looking at. Across from the 90, that one's always called the hypotenuse. Then from the angle that we're looking at, the one you go across the triangle to get to is called the opposite side. And the one that's right next to the angle, that's not the hypotenuse, the leg that's next to the angle, is called the adjacent side. So hypotenuse across from 90, opposite across from the angle that we're focusing on, adjacent next to the angle we're focusing on. Sine, cosine, and tangent are the names that we give to ratios of those sides. Sine is opposite divided by hypotenuse. That ratio is sine. Cosine is adjacent divided by hypotenuse. And tangent is opposite over adjacent. Anytime this angle doesn't change in size, if we have two different triangles that have the same angle in them, they will have the same ratio. They will equal exactly the same thing. But if we change the size of the angle, then the size of this ratio changes. So sine, cosine, and tangent, the numbers that those ratios are equal to depends on how big the angle is. But any triangle that has the same angle will have the same ratio. Okay, so one way to remember this is with the little nonsense word SOHCAHTOA. If you can remember that word and remember how to spell it, that helps you remember which one is which and what to put on top of each ratio. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That's a little quick review of the trigonometric functions. Let's use them to solve a problem that's given to us in word form. We don't have a picture. Coming up with the picture may be helpful. So let's get ourselves a picture of this. We've got a small rectangular park. Okay, let's get a rectangle. And the opposite corners are joined by a diagonal path. So from this corner to that corner, there's a path. And likewise, there's one from here to there. Each of those paths is 250 meters long. So this whole thing here, 250 meters. So is the other one. We're looking for the dimensions of the park. We're looking for the length and the width of the park. If the paths intersect, so here's our two paths, where they intersect here in the middle, they make a 20-degree angle. Well, obviously they make an obtuse angle and an acute angle, but we must be talking about the acute angle here is 20 degrees. Okay, so we're going to see how our sine, cosine, tangent stuff can help us figure out how long and how wide this park has to be. Let's look at this let's look at this triangle right here. It's not a right triangle, but let's look at it anyway. Because this is a rectangle, the diagonals are both the same length, and they have to meet exactly at the center. So this is 125 here, and this is also 125. The number is not all that important. The fact that they're the same is. Because those two things are the same, we know this thing is an isosceles triangle, which means these two angles here have to be the same size. And if that one's 20, in order to get the triangle to add up to 180, we need this to be 80 degrees and this to be 80 degrees. Now that we know that, we can kind of get this triangle out of our way. Let's get rid of it. And as a matter of fact, let's go ahead and take this diagonal out of the picture. Now this 20-degree angle doesn't really apply to anything anymore because I don't have that in the picture. That 125 isn't anything. This 125 isn't anything. This 80-degree angle here, yeah, that's not really anything that's left in my picture because it needed that other diagonal, so I'll take that out. But this 80-degree angle, ooh, that's still this angle. And now, this is a right angle because we know we have a rectangle. So look at the right triangle that goes right here. In that right triangle, here's an 80-degree angle. The length is the opposite side. The width is the adjacent side. And the 250 meters, the path, that's the hypotenuse. So if we want to find the length, we could say the sine of 80 degrees equals opposite over hypotenuse. For opposite, I'll use the letter L since that's what I called the length. I'll use the letter L. I'm going to use a cursive L so it doesn't look like a 1. Opposite over hypotenuse, our hypotenuse is 250. And if we're looking for the width, the cosine of 80 equals the width. I'll call that W over the hypotenuse, 250. So now all we need is a calculator to tell us what the sine and the cosine of 80 degrees are. So we'll just use this one. So the sine of 80 degrees, sine of 80. Oh, that number doesn't look all that good to me. I better check my mode. If I look at the mode, I want to be in degrees mode. So I'm going to change my calculator, make sure I'm in degrees mode. Now the sine of 80 is 0.9848. So back over here, I've got 0.9848. That equals L over 250. Put this number over 1 if you feel like it in order to do a fish. So I want 250 times that 0.9848 number divided by 1. So I'm going to take 250 times my previous answer and get 246.2. My length is 246.2. Now if we wanted to, we could use Pythagorean theorem to find the width, but since we're doing trig, let's do trig. Cosine of 80 is 0.1736. Cosine is 0.1736. That equals W over 250. Put that over 1 and do the fish. So we want to take 250 times the previous number. And we get 43.4, and that's our width.